Okay, our second application to hydrostatics are forces on a submerged planar surface or a flat surface. So you have some flat surface, some object is underwater or under some fluid and it has a flat side, and you want to find what is the total force on that flat side due to the pressure. Okay, if you remember, pressure, the definition of pressure is force over area, so force is pressure times area. But now, unless that surface is horizontal, the pressure is going to be changing over that area. Okay, so it turns out that if you have some flat surface at some angle, you can still use force equals pressure times area, but the pressure you have to use is the pressure at the centroid of that surface, and we call it center of gravity. Centroid and center of gravity are the same if it happens to be a surface that has the same thickness. So for whatever reason, we use CG for center of gravity, which really means the centroid. Okay, so basically, if you can find that pressure at that centroid, just multiply by that area that pressure is acting, or the whole submerged area where you're trying to find the force, and you're going to get that force. All right. We'll also have to figure out where that force acts on the plate, but we'll do that next time. This time we're just going to find the magnitude of that force. Okay. The force, by the way, due to pressure, it's always going to act towards the surface and normal to the surface, or perpendicular to the surface. Okay, so here's an example surface. So this one, from the side, it looks like just some rectangle or something. But if you look at it, let's say you're looking at it normal. So here's an eyeball. So this is an eyeball. And I'm having trouble drawing my eyeball here. There we go. So there's an eyeball. It's looking normal to the surface. And this is what it sees. Normal to the plate. Okay, so once you know that shape, you can figure out what that centroid or that center of gravity is. And that's the little circle with the X through it. Okay, normally it's not a complicated shape like this. It's some circle or rectangle or something, and you can figure out what the centroid is pretty easily. Okay, so you have that point, the center of gravity. To find the pressure at that center of gravity, remember, pressure in a hydrostatic fluid just depends on the fluid and the depth. Okay, so at that point we need to know the depth under the surface of that fluid. Okay, so from whatever interface between two fluids you have here. So, but it's got to be a depth that is vertical. Okay, vertical depth, because remember, it's always in the direction of G. Our delta Z, we always put our delta Z in the direction of G, or gravity. Okay, so if we look at this case, if we look at P here at the very top, well, remember P, or delta P, P2 minus P1 equals gamma of the fluid times delta Z. Z2 minus Z1. Okay, our Z2 minus Z1 is just H1. All right, so what we have is the pressure here, P1, plus rho G times this H value, and that is going to give us the pressure at the top. Okay, we could do the same thing at the bottom and just use H2. Okay, so basically the pressure anywhere is just going to be P atmosphere, or whatever the pressure is here. In this case, it's P atmosphere, plus rho G times whatever H value you're at. Okay. So let's define Y. Okay, what we do in these kind of problems with submerged planar surfaces is define Y as going up the surface, starting at the center of gravity. Okay, so it's starting at CG, really the centroid, and going up towards the free surface, but along the surface. Okay, so you could figure out for any H what Y is and vice versa just using trig, okay, and that theta. So since Y is going to vary linearly with H, just by that trig relation, P is going to vary linearly with y. Okay, so P is going to go up linearly with y. And if we draw a load diagram, this is what we're going to get. We're going to get a line. We got P1 here, which is this. We got P2 here, which is that. And everywhere in between is that equation. It's going to be a straight line. So basically, you just end up with a distributed load. Okay, so this is just like strengths problem or statics problem. Okay. So if we were looking for the bottom, you know, if this also has water, say, on the bottom, we could do the exact same thing. Use these H's all the way up to the top. And the only difference that we would end up having is our force now would point upwards instead of downwards. Okay. So this applies which side of the surface you're looking at. It doesn't matter. Okay, so in order to do this statics problem now and find the resultant force, what you would have to do is integrate that P, which is just a linear equation with respect to H, over the whole area. Okay, so the first part of that, if we plug in P atmosphere equals rho G8 or plus rho GH for our P, the first part of that, the P atmosphere dA, well, that's an easy integral. It's just P atmosphere times A. The second part turns out, this is through the definition of the centroid, this H dA integrated over the whole area, and you're going to get integral of H dA is going to equal H center of gravity times A. Okay, it's kind of like the definition of the centroid, which you probably did in statics class. Okay, so at any rate, what you end up getting is this is your equation. The total force due to the pressure on the top of that surface is P atmosphere times A plus rho G times HCG A. Okay, so pull that A out, P atmosphere plus rho G HCG, well, that's just the pressure at the center of gravity. That's what this is. Okay, PCG then, P atmosphere plus rho G HCG. And again, if you are using gauge pressure, that P atmosphere is actually 0, and your answer will be in gauge pressure then. So that's all it takes in order to find the force on the top of the plate. You got to figure out what that HCG is, so figure out where your centroid is, and then look for the vertical distance. That's always the key. People try to look at maybe this distance, but it's always got to be the vertical distance up to that known pressure point. That, in this case, it's P atmosphere. Okay. So if you can find P at that center of gravity, that centroid, then you're good. Also remember, the other thing that people forget, when you're finding that centroid, look normal to the plate. Don't look at it from like this direction or from the top. You gotta look normal to the plate, okay, when you find that centroid. All right, so we're ready to find the forces on submerged planar surfaces, and you can go ahead and finish your quiz.